Okay, good morning. Assalamualaikum. Good morning, everyone. All right. Are you ready to start? Okay, I don't have enough quorum yet. I suppose I should have 300 plus students. Okay, the counting, I think does not suggest 300. But anyway, let's start the session. Okay, so this is going to be our first lecture session for ITS6304, Operating Systems and Computer Networks. All right. So I'll be teaching you all. My name is Dr. Siti Zainab Ibrahim. You can call me Dr. Siti or Dr. Zainab. All right. I'm the module leader for this course, for this module. And also I will be teaching you all in the lecture session as well as the lab and tutorial. And there will be one tutor, Mr. Chew Kok Kyong, which will also assist me on the tutoring as well. All right. Okay. So I would like to welcome you guys to this trimester 9, 2024. Okay, so I'm pretty sure you have logged into my times and you have looked at my module, Operating Systems and Computer Networks. So basically I have uploaded all the materials needed for the course, but not all of the materials because I'm revising the tutorial as well as the practical labs as well. Okay, so eventually the tutorial and lab will be updated, okay, accordingly when they are ready. All right. Okay, so for today's lesson on the first lecture, I would like to introduce you to this course first. Okay, if you looked at the my times, I have uploaded this module information. Okay, so you can download this module information. All right. Essentially, I'll briefly go through this module information because I think it is quite important as well for you to know why you need to learn this course and then what you need to achieve at the end of the course. All right? Okay, if I'm going too fast, let me know as well. Okay, anyway, before I introduce this lesson, okay, some of you may be a little bit too shy to ask questions. All right? So I just prepare this Slido, so you can scan the QR, go into the Slido, all right? And if you do have any question to ask, okay, while I'm briefing you all in the module, you can ask the question in the Slido. Then later on, at the end of the session, I will go through the Slido and read the questions if you have any. Answer the question, okay? Right, so you can join this one. Okay, I'll give you a few minutes, few seconds, okay, to scan the QR, right? So as I presenting the slides, okay, the information, if you do have any question that you want to clarify, you can ask the question in the Slido. Or else you can also wait until the end of the session, you can raise your hand and then ask the question, okay? All right. Okay. All right, so I will answer to that one later. Okay, let's go to the, class attendance. I will display this later. Okay. All right. So for the module, okay, this module, remember the code is ITS6304. Okay, Operating Systems and Computer Networks. Basically, this module combines two important topics, which is operating systems and computer networks. All right, it's 4 credit hours. All right, and then I'll straight away go through the MI. Okay, MLO. Okay, at the end of the course, okay, so we expect you to be able to achieve these 4 learning outcomes. All right, so I hope. Can you see? Now it's a bit better. Okay, so the first one is for you to be able at least to demonstrate the concepts and methods learned to solve problems, okay, related to flow control, error control, routing, addressing, and switching techniques. Basically, you need to be able to demonstrate your understanding and application, the ability to apply the concepts and methods that you have learned for computer networks, right? And then you will also should be able to analyze and compute data communication performance, okay, such as link utilization, throughput, and delay. The third objective that you should be able to achieve at the end of the course is for you to be able to propose a basic network operation solution, okay, through a presentation and report for a simple network. And the last one is the OS part. Okay, is for you to be able to describe various functions of operating system, okay, such as process management, inter-process management, memory management, disk access, and system I/O operations. I/O stands for input-output. Okay, your machine here has input-output. So how does it operate on your machine? So that is the essential part that you need to be able to describe. Okay, so these are the four objectives. So all the assessment, okay, design for this module, okay, will be tailored to ensure that you will be able to achieve the objective. So I will go through this part. Okay, so for this course, there will be 4 assessments. Okay, 4 assessments, 3 coursework assessment, and 1 final exam. Okay, so assessment 4, final exam, is aimed to achieve MLO 1. Okay, and then you have 3 coursework assessment that you need to complete before final exam week. Alright, so you're going to have 1 group assignment, which will focus on the networking topic. And then you're going to have practical tests. So the practical tests will be evaluated and assessed throughout your lab sessions. So make sure that you attend all your lab sessions. Okay? And then you're going to have 1 midterm test in the middle of the trimester. Okay? So these are the 4 assessments that you will need to complete in order to achieve all these learning outcomes. And there is 1 section in the MI, okay? But we hope that you will not fail the course, okay? But otherwise, if another situations happen, okay, that you need to resit, okay? If you fail your final exam, okay, you need to resit your final exam, okay? So, and the coursework as well. If you fail one of the coursework or all of your coursework components, you need to resit the coursework as well. Yes. Okay, for the final piece means you cannot resit that one. Okay, you cannot resit that particular coursework. So in this particular module, we will set the group assignment as the final piece. Okay, so make sure that you do well in your group assignment, because group assignment involve team members. So if one of the team member fail, then how are you going to work together again to do the assignment? So definitely it's not possible. Right, so the final piece will be the group assignment. So make sure every one of you has a group, okay, later in the trimester, and you should be able to complete the group assignment. Previous semester, there are a few students who do not have a group until the end of the course. Okay, so we'll try to make sure that will not happen again. All right. Okay, so basically this is the MI. Okay, if you do have any question, please ask in the Slido. Or you can raise your hand as well. So any question on the module information so far? All right. So if there's no question, I will move on to the weekly plan. Right. Yes.
How many members in each group?
Come again?
How many members should be in each group?
Okay, members should be between 3 to 5 members. Not less than 3, shouldn't be more than 5. Okay, the ideal number is 3 to 5, 3, 4, and 5. Okay, and then the members must come from the same lab group. Because we want to make sure that we can manage the huge number of students, and then the marking will be done by the tutor. So definitely you have to submit based on your lab group. So members must come from the same lab group. Okay, so let me go through the assessment. Okay, I have further detailed down the assessment breakdown. Okay, for the group assignment, it should be week 5. The group assignment detail will be released in week 5. Okay, so we can refer to this weekly plan to know what we will learn and what should be released for each week, and what you have to submit as well, okay, for every week. So please refer to this weekly plan. So you can see here, this is week 1. So basically, I will brief you on the module and also introduce you to OS. I will start with OS first. Okay, and then later in the second part of the trimester, I will start to introduce you to the data communication and computer networks, right? Okay, so here for the group assignment, I will release the details by week number 5. Okay, it consumed 20%. So basically, you have to prepare a report. Okay, a report will consume 15% of the group assignment marks, and you also need to present. When do you do your presentation? Okay, submission, you have to submit your group assignment report by week 13. Okay, and then you will need to present in week 14 during your lab session. Okay, so it's going to be a live presentation to your tutor, right? And you'll be assessed accordingly. Right, so these are the plan. Okay, for practical test, 20%, all right? So there are several activities that you have to complete, okay? So the first 3 will be the practical test OS 1, 2, and 3. So this one, you will do this in the lab. And we will encourage you to complete and submit it within the lab, okay? But of course, if you cannot make it, then we will give you an extension until the end of the week to do the submission. All right? Okay, so these are OS Linux lab activities. And then this one is the Cisco. So for this trimester, we'll be using Cisco Packet Tracer as a simulation tool. You can go to the Cisco Networking Academy and you can log in, but I will give you detail on how to register and which module you need to take in the Cisco Networking Academy. But this will be the tool that we'll be using this semester. And this simulation tool can run on all operating systems, Windows, Macintosh, as well as Linux. So you can start downloading and see how it works. Okay, midterm test. Okay, midterm test will be held in week 7. During the lecture session. Okay, so what I plan to do is that in that week, there will be no practical labs, okay, but the tutorial will be on for you to be able, for us to be able to do some revision to help you to prepare for your midterm. So that's the plan, okay. So that one is midterm test, and then of course the final exam, 40%. So this one will be at the end of the semester. And I target that by week 15, I will be able to release your coursework marks. So once the coursework mark is released, there will be no changes to that coursework marks anymore. Okay, so if you want to appeal, if you want to, revisit some of the assessment, please do so before I release the coursework marks. Right? Okay, clear? Okay, good. All right. Okay, now, let's move on to some class rules. Okay, you can visit this link. Okay, so these are some of the class rules that I expect you to adhere to, and myself as well. Okay, so I'm expecting you to be present and on time to the class. Okay, don't be late, because if you are late, you are missing some of the points. Okay, and I will not repeat that point anymore. Okay, so yeah, you either have to watch the recording or you need to read the notes on your own. Okay, and then if you need clarification, then I will clarify. But if you ask me to repeat the entire session again, no, I'm not going to do that. Okay, all right, so be present and be on time. Adhere to the deadlines. So all the deadline will be specified in the My Times, right? But of course, the submission is through Google link, not to the via My Times, because we want to mark the assessment based on lab group. Okay, so the due dates will be specified in My Times. So please follow the due dates given. If you submit late, definitely there will be some punishment. Okay, there will be some deduction, penalties that will occur. Okay, so be a learner. okay, I would like you to show some initiation in inquiring and improving your skills and knowledge. Actively listen, okay, and question whenever necessary. Okay, take notes. Okay, so take notes. Which slide that I discuss? Which slide that I emphasize to? Which slide I say important? Okay, all right. So take notes. All right, and then be accountable for your own decisions. Okay, so this is very important as well. Listen and follow instructions. Okay, so especially in the lab sessions, because it involves you doing some activities, right? So always listen to what we told you, okay, and act accordingly. If you are not so sure about what to do next, okay, so please don't be afraid to ask what you should do next to your tutors and lecturers. We will try to assist, okay? All right, before you make any important decision. And the last one that I would like to highlight here, communication mode. Any form of communication between me, the tutors, and you guys, okay, should be done during the work hours, okay, which is from Monday to Friday, 9 a.m. until 5 p.m. So you can reach out to us between these working hours, right? And how do you contact us? Okay, please don't message me through WhatsApp. Okay, in the middle of the night at 11 p.m. Okay, don't do that. Okay, so you can use, if you need to meet up to discuss some personal issues or subject-related matters, we can set up a meeting using Microsoft Teams. Okay, so we can discuss through Microsoft Teams, or what happened last semester, I will do physical consultation. I will set sometimes, I come to the office, and then we can set an appointment for you to come and meet me in the office suite. Okay, so that is another way. I also set this, if you look at my times, I set this consultation room as well. Okay, so if you cannot make it to meet me during physical consultation, you can enter this chat room, okay, and this chat room will be open every Thursday, 3 p.m. to 5 p.m. So you can enter the chat and ask the question there as well. Another way to communicate is that in the forum, especially when you start working on your assignment. I'm pretty sure at the end of the few weeks, you will have a lot of questions to ask. You can ask in the forum. Then I will share my point of view, my insights. Then everyone can see from there, can read. Okay, so it's going to be a shared discussion. Okay, so these are several ways that you can use to reach out to us if you do have any questions. All right, so I hope this is clear. Okay, so after I introduce you to this module, okay, good morning. All right, so let me answer a few questions here. Why do we have tutorial and practical separately? It's a separate sessions, but I think you will be assigned to the same practical and tutorial group. Okay, and for this trimester, it will be held in consecutively. You're going to have tutorial first, and then we will have practical after that onwards. So it's going to be 2 hours session. Okay, so we don't have, like last semester, we have 1 hour for tutorial, 1 hour for practical in a different day and different time. But this time around, we combine that into 2 hours. So it shouldn't be any issues, whether it's tutorial or practical. Okay, tutorial basically we will do revision, okay, and exercise to what you have learned in the lecture. So basically to enhance your understanding on the concept. Practical, basically you will do some practical activity using a simulation tool and specific OS. Okay, so this is the difference. All right. Okay, so I hope I answered that question. Okay, textbook. All right, textbook. I will share one link to the textbook. Okay, it's a William Stallings operating system, and also William Stallings, a book by William Stallings on data communication and networking. Okay, I will share one link for you to access the file. Okay, can we get A+? So this one you have to answer, to question yourself. This one is the question to you. whether you can get A+ for this course or not. Okay, if you're well prepared, then of course you can get A+. Can get A+, all right? So is the practical test online or physical? Practical test will be online and as well as physical. But we encourage you to attend the lab sessions because we want to make sure that you do the submission during the lab session for some of the practical tests. Okay, and if you do encounter any problem, we are there to assist you, okay, on how to move forward. So please come to your lab sessions, right? Okay, so you have tried virtualization. The minute you try to do to run your virtual machines on your Macintosh, but you have some problem. So we will try to resolve this during the lab session next week. Okay. Okay. What if you are not at Malaysia during week 14? What happened in week 14? Okay, I'm not so sure what happened in week 14. I have to double check first. Okay. I'm not so sure. I don't think there is the whole week will be a holiday. Okay. I'll let me double check. Okay, I will display the attendance at the end of the session. Okay, yes, you're going to have your individual learning week in week 8. So if you can see here in the weekly plan, okay. Okay, in the weekly plan, I have highlighted here week number 8 is the independent learning week. Okay, there will be no classes at all, right? But you will have to do some homework, that's all. Okay, lab homework. All right. Okay, and then, okay. All right. All right, I think that's all for the Slido. How do you find this course? Is it challenging? Will it be a challenging course for you? Easy. Easy peasy. Okay, if you're studying, well prepared, then it's going to be committed to the class, listen, then it will be easy. Okay? All right. Okay, so I think I will proceed to the lecture session. Okay, are we ready to start? Ready? Yes. Yes, my dear. During your first lab, we will inform you what is the format for the submission. Basically, if you look at my times, let me go back here. Okay, you can see here, practical test or S1. This is for the first lab next week. Okay, we already give you the activities that you have to do, and also we already give you the template for the report. So basically, you just need to update the template and submit the template. That's all. All right? Okay, so everything is has been prepared for you, okay, for the submission. Okay, so let's move on to the lecture number 1. So basically, how many of you are using Windows operating system, Microsoft? Microsoft users? Okay, don't feel shy, just raise your hand up and high. Okay, all right, good. Macintosh, iPad, Mac users. Okay. Anyone is using Linux operating system? Do you have any experience using Linux before? No. Okay. Okay. A few of you have experience using Linux. Right. So that's what basically we will introduce you later on to learn how to use Linux. But basically, okay. Okay, what we are going to discuss today, okay, is I would like to introduce you to operating system. All right, so you can see here in the lecture notes, this is chapter number 2 already. All right, because I'm basing the lecture on this textbook, and the topic for the first topic in the syllabus, okay, come from this chapter 2. So that's why you're going to see the number of chapters is a little bit, does not follow the order, because I picked the chapters according to your syllabus. Okay? Right. Okay, make sure you come back as soon as possible. Okay, right. Okay, so chapter 2, operating system overview. Okay, so what is operating system? So I'm pretty sure you have used operating system already, okay, since you purchased your machine. A machine without operating system is useless. It's just a machine, you cannot use it. Okay, so in order to be able to use that machine, especially in this respect, machine is your laptop or your PC, okay, or your tab or your phone. It requires an operating system. Okay, so what is operating system? It is a program, okay, a software program. And this software program has two functions. Okay, so what are the functions of operating system? So first is to control the execution of application programs that run on the machine, so that you can run the application programs. Okay, you can run Word, you can run Excel, you can run whatever. Okay, games. Okay, and it also acts as an interface, middleman, okay, between applications and hardware. Okay, your Word requires you to use keyboard, mouse, processor to process, okay, to save the file in the hard disk. So these are, you need these resources for you to be able to use the application, Word application. So OS will help you to intermediate, okay, between the application and the hardware resources. All right? So these are the two main functions of operating system. Right? So the main objective of OS is to make sure that users can conveniently use the application programs. Okay? And efficiency. It also wants to make sure that you can use the hardware resources effectively, efficiently. Alright? And the OS also is designed in such a way that the operating system will be able to evolve, to grow with the new, in order to be able to support new application and to support new hardware features. Okay, it does not stop with one variant. You can see from Microsoft Windows, when I was studying, we have Microsoft Windows 3, okay, and now we have what? Microsoft Windows 11, okay, Linux as well, Macintosh as well. When I was studying back 10 years ago, I bought the Macintosh machine, which is so heavy, and now it's obsolete already. Okay, after 10 years, you cannot use it anymore. All right, I need to buy a new machine. All right. Okay, so basically, these are the main functions and objective of operating system. Okay, so now, if you look at your machine, there are two major components. One is the hardware components, and another one is the software components. Okay, in the hardware component, this is where you're going to see your I/O or input-output devices, your networking device, your wireless card, your network card. Okay, you have your main memory, your RAM. Okay, and then you have the buses, the interconnecting components, and also the processor. Of course, you need a processor to process. So this is the hardware component. The hardware component will remain dormant if it does not have any software to use those hardware. So in the software, you can see, of course, on top of your hardware, you must have the operating system as an intermediary interface. Okay, and you have the application programs, all the software that you use to do your daily task. Okay, so you have your application programs on top of your operating system, and these two will be able to communicate using some libraries and utilities. Okay, remember, on your application program, you have so many types. You have games, you have Microsoft Word, Microsoft Office. What else do you have? So many things. Okay, and you only have one operating system. Okay, so how does this operating system support all these various applications running on your machine? So using this library and utilities. Okay? Alright, so in between here, you're going to see what we call the interface program. Alright, so these are the 7 services provided by operating system. Okay, so one is to provide the environment, the platform where developers, programmers can use your operating system to develop new programs. Okay, so that's one, program development. The operating system also should be able to make sure that the program can be executed. Okay, you can execute program. It also makes sure that the program that you have developed can access all the input and output devices on the machine. Okay. It also gives you access to file. You have file. You can access the file on your machine as well. System access. System. What do you understand with this? System access. User access. You know, your machine, you can have many users use your machine. You can create a different user account. So OS also can provide access to the user to access the system. Right, to different users to access the system. And then the OS should be able to detect error and also to be able to respond to errors. There are sometimes when you run some program, there are some errors that you cannot access some main memory sector and whatnot. Or your printers is not available yet. They'll give you some error message, right? And then accounting. Accounting means it will prepare some report, statistical report and usage report in terms of how your OS has been used, okay, in terms of how resources has been utilized and whatnot. Okay, so this is the accounting part. All right, so these are the main, the 7 main services provided by operating system. All right. Okay, so any question so far before I proceed? Clear? All right. So now we look at the interfaces. Okay, as I mentioned just now, there are 3 interfaces here underlying the software part. All right. So you have application programming interface, API. So I'm pretty sure you are familiar with API. Have you heard API? No, some of you heard of API because if you want to attach something to your software, you need to call the API. So it's kind of a common words, okay, across the programmers. Programmers should be familiar with API soon, sooner or later. Okay, and then you have ABI, Application Binary Interface. And then you have here instruction set architecture. So these are the interfaces that enable your application programs on the very top layer of your machine to be able to use all the hardware at the very bottom layer of your machine. Okay, so now let's look at the interfaces. All right, you have ISA, instruction set architecture. Okay, so this one is defined as the repertoire. It's like a library of machine language instructions, okay, that a computer can follow. And this is basically the interface boundary between your software and hardware. So the ISA here is depending on what processor you are using. If you are using Intel Core, then the machine set instruction will be different from AMD Core, okay, and so on, right? So basically what I'm saying here, the execution hardware here, the processor that you use will determine what machine instruction that your machine need to use, all right? Okay, and then you have ABI, Application Binary Interface. Okay, for this ABI, it defines the system call interface to the operating system and the hardware resources available in the system through the user ISA. If you can look at here, the ISA here is the interface between the libraries and the operating system. And then the last interface that you have here is API. Okay, so the API here, it gives program access to the hardware resources and services available through the ABI as well as the ISA. Okay, so basically this one is interfacing the different types of application programs to the library supported by your operating system. Okay, so I hope you understand these different layers of your machine. Okay, right. Okay, now let's move on to the next one. Okay, so the OS is responsible to control the use of a computer resources such as I/O, okay, main and secondary memory. Main here refers to your RAM. Okay, your RAM, your cache that you have on your machine. Secondary storage here refers to your hard disk. Your hard disk is something that you can plug in and out from your machine. Okay, your USB. What else? What type of other cloud? Okay, cloud storage and whatnot. So those are example of secondary storage. Okay, and then of course it also have control in terms of how program can utilize the processor execution time. How long each program can run on the CPU. Okay, remember one CPU can only run one program. It seems to us like on my machine here I have so many things open. It feels like the CPU is running all the program together. No. Okay, the real truth is one processor can only run one program. But of course it's too fast, you're not able to notice the difference. Okay, between the switching of applications by the processor. Alright? Okay. Okay, so basically the operating system as resource manager, it functions in the same way as ordinary computer software. Okay, and this operating system will definitely executed by the processor. Right? And it frequently relinquish control and it must depend on the processor, okay, to allow it to regain control. Okay, of course, to control the use of the system, it must be able to control the processor. Okay, so have you learned computer organization and architecture already from previous semester? Okay, I'm pretty sure you have seen this diagram in one of the slides. Okay, so this is your computer systems. Okay, you have memory, where this is where your operating system software is residing. And then this is all the part where it stores the programs and data. User programs and data, user data. You have processor, you have I/O controller that allows you to access your I/O devices accordingly. And you have also an I/O controller that allows you to access the storage. So you can see here in the storage, you have your OS software stored in there, your programs and also your data. So the main resources are basically managed by the operating system. And some portion of the OS will be stored in the main memory. So it will be executed real time. Alright? And this portion includes kernel. Kernel. Okay? So kernel is a nucleus, the core of operating system. And the core, what does it contain? The core contains the most frequently used function in the operating system. Okay, so this is what we call kernel. Alright, so this operating system should be evolved. Okay, should be evolved. Why it should evolve over time? Because to cater for the upgrades of hardware. Okay, your keyboard, your hardware will become much more complicated as time passes by. So your OS should be able to cater that upgrades. Okay, there will be new types of hardware introduced. Okay, for example, your wireless LAN. Okay, you know, previously it was using different models, so now it uses different speed and so on. Okay, new services. Okay, so new services comes in to the market, so it should be able as well to evolve to this. And fixes. Sometimes you need to upgrade your patch to your operating system. You receive news, okay, you need to upgrade some security patch or whatnot. Okay, so you need So your OS should be able to evolve based according to these fixes as well, to support this fix. Okay. So these are the 4 reasons why your OS should be evolved over time. Alright. So when your operating system also evolve, okay, grow with time. Alright. So in the early days, when the operating system was introduced, okay, it was a serial processing, called serial processing. What does it mean? Serial processing. Serial processing means this machine do not have any OS. It's just a big bulk machine. So if someone wants to do some processing on that machine, he need to register first, booking a session, okay, using a hard copy log sheet. Write his name, I want to use this machine from this time to this time. And then when the time comes, he go to the machine and then he start to program the machine to do his job. Okay, once he get the output, okay, make sure before the end of the time, then he will leave the machine. So the machine can only do one job at a time. And the usage must be reserved. So this is what we meant by serial processing. And then you start to have what we call simple batch system. So simple batch system, so now you start to have some form of operating system. Okay, so user will have no longer direct access to the machine, so he does not have to book the machine and go to the machine and use it. Okay, but what he need to do is that he need to submit the job to the computer operator. There will be one lady, okay, or man working as an operator who will receive all the jobs from the user. Okay, and then this operator will collect all this job and then put it into some input devices. Okay, and then the monitor here. Okay, this is the operating system. The monitor will process all the job in sequence. Okay, and then after the monitor has processed the job, it will inform the operator that the job has been is finished processing. Alright, so this is the simple batch system. Alright, okay. So I will move on to the next one because I think time is a bit moving quite fast. Okay, and then the next batch system. Okay, we have multi-program batch system. Okay, so what does it mean here? So previously we have uni-programming, meaning that the machine run one program, okay, and then the program may need to use some I/O. Okay, so then the program waits and then execute again and then wait. So most of the time is spending to wait for the I/O completion. Imagine this is back in 1990s. To do the printing, it takes almost half an hour. Okay, print and then continue executing again, wait for another half an hour. So basically, the processor is not being efficiently used. Alright? So therefore, they introduced the concept of multi-programming. Okay, why not, while the program A is waiting for I/O to complete, why not the processor run another program? Then we can effectively use the processor. Okay, so this is what we meant by multi-program. So this, the first two line here is referring to uni-programming. So when we combine into multi-programming, you can see now you can have 2 programs running in parallel. Okay, all right, not in parallel, in consecutively. Okay, so without wasting the processor time. So this is multi-programming, and you can read through. And the last evolution, the last stage that you can observe today is the time sharing system. Okay, so time sharing system, this one can be used to handle multiple interactive jobs. Okay, meaning that the processor time now is being shared across multiple users. Okay, so previously all the jobs are running in one machine. So now why not we create one server, one central machine then users can access the server via terminal, okay, and then they can do the job, okay, from their machine. But the job is running in the server. Okay, so that's what we meant by time sharing. So the idea of time sharing now is like when you access your My Times. You access your My Times from your machine. The My Times software application is running on the server somewhere in level 7 in one of the blocks. Okay, so that's what we meant by time sharing. You are sharing the processing time across multiple users. Okay, so I hope I have illustrated to you the difference between these 4 evolution here. This one. So you need to be able to differentiate how the operating system works in serial processing, simple batch system, multi-program batch system, and also time sharing systems. Okay, and the rest we will discuss in the tutorial section. Alright? Okay, so before I end, okay, any question up until this evolution? Kernel. Kernel is the nucleus. If you learn, I'm not so sure, if you take robotic, one of the program, you have this OS. Okay, let me find another. Okay, so your system here, your operating system here has a lot of functions. You can see here, you have, this is the utilities given by your system. You have calendar, notification, access to some of the devices like your screen, okay? You have access to the speaker, okay? To the microphone, right? So all these are enabled by your operating system. Okay, there are some utilities which are the core of the operating system. For example, the switching between applications, scheduling. How the OS schedule which program to run. This is core. Okay? So the calendar one is not core. You can actually remove the calendar if you don't want to. So it's not a core function of operating system. But operating system does provide that service. So the kernel is the main nucleus part, is the most important part of the OS that contain the most frequently used function in OS. Okay, especially the scheduling part. You can go down here. Okay, let me show you the kernel part. You can go down. This is the evolution. Okay, major achievement here. You have process. Okay, so this is what I meant by process. So basically, the operating system should be able to support various type of processes. Okay, and when we talk about process, this is what we meant by process. Okay, and then memory management. Remember, in your hard disk, in your machine, you have so many types of memory. You have RAM. Okay, you have cache. You will learn later cache. Okay, and then what else? Your hard disk and so on. So basically, your OS also need to manage access to these different types of main memory. Okay, and then you have information processing, protection and security, how to secure and protect the information in the OS, how to schedule the processes, okay? And then here, we have microkernel. Okay, so basically the kernel, oh, okay, I think it stops. Can you see? I think it stops. All right. Okay, so basically the kernel, if you can refer to slide number 37. I think it doesn't work. Okay, I need to show you your cams. Okay, let me settle this one first. proceed to discuss the rest of the slides in the tutorial. Okay, but let me try to resolve this so that you can scan your attendance. Alright, so let's resolve this first. Okay, so let's settle your attendance. Okay, so make sure you scan this QR, you enter your passcode and then update your attendance. If you do have problems later on, please come forward. I will update your attendance manually. Okay, so the first lecture is very much theory, and next week we're going to have some calculations and whatnot, okay, for you to do. So please make sure, don't come single-handedly without bringing any paper and pen. Please bring some paper and pen, or at least your tab so that you can draw something, okay? All right, so that's the requirement for next week. And one more, homework. I need you to do some homework before next lab tutorial. Okay, I need you to do some homework here. You can go to your My Times. Okay, because we are using Linux operating system for your lab. Okay, for Windows user, I would like you to install these two types of software. I have prepared the guide. Okay, you follow the guide and install the two software accordingly. I need you to do so before you come to the lab because the size of the operating system is huge. It's around 6 giga. Okay, 6 gig. So you have to download this from your home. Okay, and then at least you have the copy already by the time you come to the lab. Don't download this in the lab because we are having sharing network bandwidth. So definitely it's going to slow down your process of downloading. Okay, so please complete this homework before you attempt the lab next week. Okay, if you do have anything to ask, you can ask in the forum. Yes, you can download Ubuntu if you want. At the moment, I'm using Ubuntu. For those who plan to take cybersecurity class, you can. Have you heard Kali? Kali, yes. You can. Hang on, let me show you. You can go to Kali Linux. Okay, so you can download Kali as well. So I'm quite open what variation of OS you want to run in your system. What I show in my notes is a Ubuntu. Okay, you can also download and install Kali. Same process. Right? Okay, all right. I think that's all for today's lesson. Thank you so much. So I'll see you guys next week.